Welcome to Func Prog Sweden 8. First, I would like to thank all recurring viewers. Welcome back, and to all new viewers, welcome to Func Prog Sweden, the meetup where we explore functional programming. And let's head over to the agenda. So today I will do a short intro by me, Magnus. Then we'll have the first presentation. Real-world functional programming in Scala using ZIO, a tour by Yonas. Then we'll go over to betting our startup on Clojure by Nick, and then in the end I'll do a schedule and for the rest of the year, and then a summary of today. First, I would like to thank our video sponsor, Adabeat. Adabeat is an IT consultancy company with offices in Stockholm and Vietnam. And if you want to know more about Adabeat, check them out in social media or on their webpage, adabeat.com. And if you want to support the community, which you of course want to do, head over to MeetUp, join the group, or please subscribe to our YouTube channel. And if you really want to support us, head over to the merchandise store at funcprogsweden.myspreadshop.net, where you can buy t-shirts like this. We have coffee cups like this with the nice logo on. And I also would like to do a shout out to Peter in Houston. Thanks for buying one of our nice hoodies with the Func Prog Sweden logotype on. If you have questions during the meetup, don't hesitate. Ask them in the chat, and I will read it to I will ask the presenter or read it to the presenter, so they can ask them ASAP, or answer them, I might say, ASAP. With that, we'll head over to our first presenter. Jonas, welcome to Func Prog Sweden.
Thank you. Excited to be here.
Yeah, it's really nice.
Yeah.
Yes. The stage is yours, Jonas.
Great.
Before Jonas will start, I will say a couple of words, and Jonas will have the possibility to hook up his laptop.
All right.
Yeah.
Let's do it.
Yes. So I'm really excited, because Jonas, I didn't know, but apparently we have people teaching Scala at KTH. I didn't know this, but Jonas enlightened me before this presentation. So I'm super happy that I found you and that you're here.
Yeah, I'm really happy to be here.
Yeah, you're welcome.
Yeah. All right.
Hit it away.
Yes. As you can see, my name is Yonas Ghidei. So I am a Scala engineer at Ziverge, which is a creator of open source library ZIO, which we will talk more about later. Previously, I was a Haskell engineer at Klarna and a Scala engineer at Rocker, and I was doing a host of different languages at Viserti before that. So I'm interested in functional programming languages, types. Yeah, I think let's get going. So first, let's talk about Scala. So Scala is a language that was created by Martin Odersky, and he set out to create a language that was wants to be a mixture between two different programming language paradigms. So he thought that object-oriented programming and functional programming are complementary rather than contradictory. And his idea was that we could use functional programming for transforming and modeling data, and we can use object-oriented programming to organize and structure our codebase. And as we all know, any language is dependent on its ecosystem, and ZIO is a next-gen framework for building cloud-native applications in Scala. And ZIO is kind of a new library. It's been around for a few years, but it has its 2.0 released a couple of months ago, and it's been rapidly growing popularity. ZIO has seen a lot of growth this last year, especially after being a challenger of the status quo from ZIO to 1.0. And ZIO, the framework, gets its name from its core data type, which is also named ZIO. So it's a data type with 3 type parameters, as we can see here. And its core it's a data type. Like the core idea of it is to describe a workflow. So it has some similarities with like a promise in JavaScript or a completable future in Java, but with a core difference. ZIO is a pure value. So it's a value describing a workflow, which will later be executed, and then it will perform the computations that it describes. So this workflow can have asynchronous and concurrent properties, and we're going to look into that more later. So let's get back to the 3 type parameters that we see here. So we see that we have a ZIO, and it has an R, an E, and an A, and we're going to go through them one by one to explain what they mean. So the A here is the success type. So this is the type of the value. This is the type of value the ZIO-REA can succeed with. So when this computation or this workflow has finished running, or when or if it has finished running, it will succeed with this value A. And E stands for the error type. So this is the type of error the workflow can fail with after it has finished running, or if. And lastly, the R environment, the R parameter, which is the environment type, is the contextual data needed to run the workflow. So a helper conceptual model you can think of this is a ZIO-REA could be thought of as a function from R to an either EA. So given on R, it can produce eventually a value of A, or it can fail with a type E. So this is not an exact, precise representation, but it can help you think about how this will work. All right, so enough of the conversation here. I think we should go ahead and do some live coding to showcase how ZIO works in the real life. And while we're at it, we're going to take a look at some of these different bullet points here. So we're going to take a look at code organization, and we're going to have in mind what we talked earlier about what Martin Odersky set out to create when he created Scala, how he wanted to use object-oriented programming for structuring your code base, and how ZIO leverages that vision. And then we're going to take a look a bit on dependency injection, how ZIO does that for you, and then some common everyday use cases like error handling and retry policies. Okay, and we're also going to take a look at testing if we have time. So we're going to see how we do that. Okay, so let's head over to Visual Studio Code here. I'll change this to full screen. So for the non-Swedish viewers, we just had an election in Sweden, so I thought it'd be fun to build a kind of, let's call it decent election system to showcase ZIO. So we're going to take a look at that. So I think first, let's run, I think we can take a look at that by just running. So let's run main, and then take a look at the HTTP server here. So we're going to start our server, and then we can explain it as we go. So we're going to head over to localhost 8080 docs, and we're going to take a look at what we have here. So our application is an election system that exposes 3 endpoints, and they're going to be get endpoint to retrieve a vote based on your national identification number. You're going to be able to create a party using this put endpoint by specifying the party name. So we have some example data here. This Func Prog 2022, and then you're gonna be able to also create a vote here by specifying your name, last name, national ID number, and also the party you want to vote for. Okay, so this is like the end result. This is what we want to accomplish. Okay, so let's head over back to the code. Before that, actually, let's stop this server and also switch branch to presentation. So I prepared a presentation branch that stubs out some of the implementation so that we can finish the project together. Okay, so before we go ahead and look at the source code, I just want to quickly give you a look on our database model. So we have 3 tables: a person, a party, and a vote. Okay, so a person, as we saw before, is a first name, last name, national identification number, and then a party has a party name, and then a vote. You can register a vote based on your national identification number and also the party you want to vote for. So nothing fancy going on here, just to give you an intuition of our domain. Okay, so let's orient ourselves in this code base. The this is using standard SPT Scala structure. So we're going to go to source main, and then we're going to look under Scala to find our sources. And we have a few different packages. So we have config, and we have a database service, and we have our model, and our model represents our data types that we saw. So we can take a look at, for instance, a vote. You see here that a vote is composed of a person and a party. And if we look at party, you're going to see the first name, last name, and a national identification number. So NIN is just short for national ID number. I was a bit lazy when writing this code. All right. And then we have also our routes, which is our election server. And this is the code that writes that writes this. So the endpoints. So that describes these endpoints and the handlers for them. And then we have a validation package, and we're going to get back to why we need that later. And here we have our main election service. So this is where the bulk or the meat of our code is going to lie. So this is the stuff we're going to implement. And I am just going to minimize this as to not distract you from stuff you're not ready to see it. So, okay, so let's take a look at this. Okay, so we have a trait. So a trait in Scala is an interface in Java. So, and also we have an object, and this is the way you create singletons in Scala. So the way the singletons are used are for namespaces. So you can put stuff related to the election service in this namespace here. So we're going to see what kind of stuff we're going to put here, but it can be data types related to the election service and stuff. Okay, so before we're going to get into that, we're going to take a look at our interface. So this election service has 3 different methods. Okay, and it has, so the way you read this is that this is a definition. So this is the name of the method. This is the parameter list here, and this is the name of the first parameter called party, and the type. So the way you read this is I have a parameter called party, and the type of that parameter is also party with capitalized. And this is what we looked at earlier. So this is just a class with a party name, one field. Okay, so, and this is the return type. So the return type is a ZIO. So remember that the first type parameter was for the environment, the middle type parameter is for the error type, and the last type parameter is for the success value. So the way we read this is we have a ZIO that can run in any environment. So what we're doing here is we're cleverly using the Scala type system to signify a workflow that can run in any environment. So this ZIO does not need any additional contextual data to be run. And also here, if we look at the error type here, it's typed to nothing. And again, we're using the nothing type because the nothing type in Scala has no values. So if we have the error types typed to nothing, this means that we have a ZIO workflow that cannot fail with any typed error. Okay. This does not mean, however, that it cannot fail at all, right? We're still bound by the reality of the world, so if this machine has an out-of-memory exception or a real fatal error, then of course this is not going to succeed. But we want to, in ZIO, we think it's useful to separate those 2 errors. The failures that we cannot deal with, and the domain errors that we do, in fact, want the upstream to deal with. So, and then the return here, the success value, would be a party. And then we can take a look at the other 2 methods. And again, those are very, very similar. So the difference here is that this one, register vote, can fail, can in fact fail with a domain error. And that will be invalid input. And we'll take a look at that later on. Okay. And also for the people not knowing what unit is, this is the type void in Java. So this is just a value with no additional information. So yeah, we'll take a look at that later on too. Okay, so let's head over to this singleton, and we're gonna try to implement. We're gonna do this, and we're gonna take a look at this here. So what we're trying to accomplish here is that we want to provide an implementation for this interface. So as we talked about earlier, we're gonna see how we're mixing OO features and functional programming features. So here we're back to OO. This is interface OO, and we're going to see that we want to implement this interface. So the way you read this is that we have a class that we call election service live by convention. So this is what we do in ZIO, and we extend this interface. And as we can see here, we have two parameters, the database and the validation service, in order to implement these methods here. So let's go ahead and take a look at this implementation. We're going to try to implement all these members. And we're going to wait with get vote and only do that one if we have time. But otherwise, we're going to focus on create party and register vote. So let's start with create party. I'm also going to remove the tree here on the side to give us more space to look at the live coding. So I hope this is a bit better. Okay, so we have this. We want to make an implementation for this, create an implementation for this create party, and yeah, we have what we have is a party in the parameter list. And spoiler alert, we're going to use the database to register this party. So we're going to go to database, which is the database service here. So we're going to use this one. And then we're going to do dot, and we're going to use our dot completion here, dot, and we're going to see what kind of methods this database service exposes. And we can see here that it's exposing insert party. This one looks like the one we want to use. And then it takes one parameter. So we're going to pass the party. And now we have a type error. So let's look at the type error here. We have, the Scala compiler is telling us that we have found a ZIO that can fail with a unique constraint violation, but what is required is a ZIO that cannot fail with any type error. So the ZIO is cleverly using the Scala compiler to tell us at compile time that we have not handled all errors. Okay, so let's see what kind of error do we have. We have a unique constraint violation. Okay, and if we go back to the endpoint, we can see that we have a put endpoint for this for creating a party. So that means that if the party already exists, we should not treat this as an error. We can simply say, okay, this endpoint should be idempotent. If that party already exists, then then it's fine. We can just say, okay, let's move on. We don't have to fail on this error. So let's recover on that. And the way we can do that is by using the catch-all combinator in the ZIO on ZIO. And the catch-all combinator expects you to recover from an error, E, we can call it E, and unique constraint violation. And this is the function. So in this function body, we have to supply a function that will recover from this error. Okay, but there's not too much to do here because we already know that this is not a problem for our application. So we can just, if we're interested, we can log this. So we can use ZIO.log info and say had unique found error, got error E, and just say ignore something, ignoring. Okay, and yeah, and then we can save that and see what the compiler tells us now. So again, there's something wrong. We have given this function a ZIO of any nothing unit, but it expects us to give us a party. So here we're saying that, okay, if the party already was inserted in the database, we can just simply return the party that you tried to insert, which should be the same, right? So what we can do is we can map over the ZIO. So we can use map, and then we can say that we can give this success value a name. Let's call it unit, and then return the party. So we can see here that this unit, this is useless information. So as we said, this is void in Java, so this doesn't help us in any way. We're just returning party anyway. So what we can do is we can use the underscore in Scala, which is don't care. So we can have a map. We can map over this unit and discard it and just return party. And this is very common in ZIO. You see this pattern a lot. So you can just use the as operator. So we can just do as, and then we'll return party. Okay. So now we're done with create party, and now we're going to head over to register vote, which is a bit more involved. Okay. So let's first read the comments here. We have what we want to do is log an entry that we've entered this function body. Then we want to validate the vote using the external vote validation service. And after getting a response, we want to handle the response. Okay, and we can see here that we have a validate vote helper function and a handle response helper function. And we also have this what we call in Scala a for comprehension. So a for comprehension is, in Haskell, it's called do notation. So the way you're supposed to read this is that this happens first. The return of this is something we're discarding. So logging just gives us unit. So we're going to discard that. Then we're going to head over here and validate the vote. And then after that, we're going to get a response after validating the vote. And then we're going to use the response in handle response. And then the result of that, we're going to discard. And then this entire for comprehension is going to yield or return unit. So this is the unit value. So this is the value unit of type unit. Okay. So we could return anything we want here. We could put vote here, but it's not interesting. So we're just going to put unit here. Okay. This is also another way to think of this is that this is syntactic sugar for two flat maps in a map. So basically, we could rewrite this code to be a bunch of flat maps and maps. So we could say underscore, and then we can validate the vote like this, like that, flat map, etc. Right? And then this would be the response, and then we would handle the response. But as we can see here, this is what is sometimes called callback hell in JavaScript, and this doesn't look too good. So we'd rather use the for comprehension that we have in Scala. So another reason for you to switch to Scala if you're using JavaScript. All right, so let's head over here and implement validate vote. So we're going to take a look at validate vote here. We have a vote as the parameter, and our return is going to be a ZIO that can be run in any context, can fail with no errors, and will yield the validation response. And we can use the external validation service to do this. So let's do the validation service. We have it here. So this is passed in the constructor. So we're going to go back to validate vote, call validation service, and then we're going to, again, do dot completion and see validate vote. We're going to use vote, and we're going to pass the vote there. And again, we're going to get help from the Scala compiler. So the validation service, which is an external validation service, can give us a validation error. And we're going to take a look at that data type and see what that is. So seal trait in Scala is a way to do a closed enum. So the way you should read this is that we have a validation error type, and it can be either one of two things. It can be a temporary error or a response error. And the way we're going to think about this in this domain is that this temporary error is an error that might go away if maybe we try again. And a response error is something that we can't really deal with in our code. We're going to probably need some manual intervention to deal with that. Okay? So let's go back here and handle this validate vote. So what we can do in ZIO is we can use a retry operator to retry. So we want to deal with if there's a temporary error, we want to retry our call to this external validation service. Okay? So we can use the schedule data type to specify our retry policy. So here we can use, let's say that we want to retry 5 times. So let's do that. So we have a schedule that, so our retry policy right now is that we were going to retry this vote 5 times. But we're going to retry this as fast as humanly possible, okay? And that might not give us time to recover, that might not give the external validation service time to recover from whatever temporary error they're experiencing. So we want to space these retries. So the way we can do that and compose policies is by using the and operator on schedules and use the spaced operator, and then we can provide how a long time we want to space. We can use just 10 milliseconds. I'm just using this arbitrarily. We can specify whatever time frame we want. Okay, so we have one more thing to do, and that is that currently we're retrying on all validation errors. But I already said that we only want to retry if the validation error is temporary. So the way we can do that is by combining the schedule with another schedule. And that we can use the recur while operator. And this will, so then we can specify that we only want to recur while the validation error is temporary. Okay? So we can see here that we have a schedule. We have a schedule that will recur 5 times. Maybe I can zoom out a bit. So we have a schedule that will retry 5 times, and it will space the retries with 10 milliseconds between each retry, and it will only do so if the validation error is temporary. Okay? And you can see here that the Scala compiler is telling us that we still haven't handled all errors, right? So if this happens for the 6th time, then we're going to still have a validation error. Or if we never had a temporary error in the first place, maybe we had a response error, then we still haven't dealt with that. And ZIO, and we already know that, okay, if the external validation service is down, then it's down. We can't really recover from that. So ZIO allows you to just say that, hey, we can't recover from these failures, so we're going to die if that happens. So the way you're supposed to read this is that we're going to validate the vote, and we're going to retry according to this policy. And if that doesn't work, then we've done all we can do. And then in that case, we're just going to die. And what die does is just moving the error channel, the validation error, to the untyped error channel. So it's going to be moved to all the errors that we were not interested in keeping track of. So all the fatal errors or all other errors, right? So because the upstream can't deal with that error either. So it's just time to give up and say, hey, let's move on. Okay, so now we've implemented validate vote. So we want to implement handle response. Okay, so let's take a look at if we get a response, so everything succeeds, we're going to get a validation response. And this validation response is, again, an enum, and it's going to tell us whether the vote is valid or invalid. So we only have 2 cases. So what we're going to do is we're going to match on that. So we're going to do match, and the language server is helping us and showing us all the cases. So this is a exhaustive pattern match. And we're going to, I like having the name before, so it makes it super clear. So we're going to add response valid. And then we're going to do question mark, question mark. And question mark in Scala is just throwing an exception. What is not compiling here? Legal start, simple pattern. Nope, that was an old error. Okay, yeah, cool. So I'm just going to remove this. Just going to remove that. So let's take a look at this again. So what do we want to do? So yeah, question mark is just is a way Scala to just specify that we want to do something in the future. We don't have an implementation. This is just going to throw in not implemented error. So nothing going on here. What do we want to do if the vote is valid? So if the vote is valid, then we can safely go to the database and say, just insert this vote into the database. So we're going to do that, and perhaps we want to do some logging. And the way we can do that is we can, if we want to combine 2 ZIO workflows or descriptions together, we can flat map. So we can flat map them like this. So inserting the vote into the database is not going to give us any interesting result. It's just going to give us a unit. So we're going to discard that unit. And then we're going to maybe do some logging, say ZIO login info. Inserted vote to database, something like this, okay? But again, this is another common pattern in ZIO where you flat map and underscore, and ZIO has a shorthand way of doing that. So we can use the shark operator here, the right shark operator, to do this. So this is a much cleaner way. So the way you're supposed to read this is that do this first, discard the result of whatever that is, and combine it with this ZIO workflow. And now we can head over to what we want to do if the vote was invalid. So if the vote is invalid, then we can't do much more, right? We want to tell whoever made the call to register vote that, hey, this vote is not valid. So we're going to use the ZIO.fail operator, and then we're going to use error invalid input, and we're going to say vote was not vote was not valid. And you can see here in the type parameter that this is being caught by this is shown in the contract of this function, that this can fail with invalid input. So if I were to put a different error here, then this would not compile. Okay, so yeah, we are done implementing this. We're done implementing this function, register vote, and I'm going to skip get vote, but we can get back to this code. Will be, you can find all this code on GitHub later on. So I'm going to post this and make it public, so for everyone to see if they're interested. But yeah, it would be very similar to what we did for create party. We just make a call to a database and do some mappings. All right, so we have one last thing to do here, and we're going to talk about something called z-layers in ZIO. And a z-layer here is so if we first talk about OO constructors, so if you look here, we can see that we have an interface, and we have a class implementing that interface. Okay, but we are all functional programmers here, or interested in functional programming, and this is not a value, right? I cannot store this election service live in a value and modify it, pass it to a different function, right? So since we are functional programmers, we want to get back to the land of values. And ZIO has a concept called Z-layers, which is a constructor as a value. And if you kind of squint at this, so it also has, this Z-layer has 3 type parameters. It has the environment type, the error type, and the success type. But instead of describing concurrent and async workflows, this is describing the construction of services. So we can take a look here. If you squint a bit, you can see that these two lines are very similar. These lines here, this line here, implementing the interface, is very similar to this Z-layer. What we're saying here is that this Z-layer, given a database and a validation service, we can produce an election service. And we're actually saying the same thing here in Scala. We're saying, given a database and the validation service in the constructor, we can provide you an implementation of the election service. Okay, so the way we do it, the way we do the same thing using Z-layers is that we call the apply method of the Z-layer, so the construction method, and we again go to a for comprehension, and then we say that we want to have, if we have a database in the environment. So let's do this, election service live, database, then we're going to copy that, validation service. Okay, so what we're saying here is that given a database and a validation service in the environment, this is how you create an election service. So here we're extracting these two, the database and the validation service, from the environment of this Z-layer. So we're not really saying how we're going to construct a database and a validation service. We're just saying that if we had those two, we would be able to create an election service. So this is the way you're supposed to read this. Okay, and now we're done with the election service, and I'm going to quickly go through how to wire up our program or our entire application. So let's head over to main. Okay. And so we have our program in app. So this is just starting the server and stuff like that. So we're going to call that, we're going to call app.program, and we're going to save. And this is using, so what we're doing here is we have extended our main with a ZIO main. So a ZIO main is going to expect a ZIO that, that is ready to be run. But this ZIO is not ready to be run because we have not specified how we're going to construct all the services that we have used in our program. So in order to specify that, we need to call the provide operator. So we're going to save here, and look what's going to happen here. We can hover, and we're going to see that we have compile time using Scala metaprogramming. We have a compile time version of our dependency graph, and ZIO knows exactly what services you need to provide in order to run. So there's no surprises at runtime. So we can see here that first we're going to need to provide some configuration for our HTTP server. So that is not very interesting. So I already prepared that beforehand. So we're just going to provide default settings, and now we're going to take a look at the more interesting stuff. So Z-layer, we have a Z-layer error, and it's saying please provide layers for the following 2 types: the election server and the app config. Okay, and if you go back to the election service, we can see that we called our live layer, we called it live, and we put it in the companion object of this interface. So by convention, we can look at the companion object of those 2 services, the app config and the election server. So let's start with the app config. So we can do dot, and we can see that we already have a live layer there that I prepared beforehand. And then we have the same for election server. So let's provide that one. And look what happened now. So now we got a new error saying that, okay, you provided the election server, and now that in turn requires the election service. So the election server here requires election service. So we already have one. This is the one we implemented. So let's also provide that one. Let's see what happens here. So the election service live. So now that we provide that one, again, now it's going to say, hey, in order to create the election service, the live version of it, we need the database and the validation service. So now we're back at how we're going to provide these things. So let's do that. Again, by convention, we know that the live implementation is on the companion object of database live. And we also have the external validation service. Then we can provide the live implementation of that. And now this compiles. Okay. So this is very interesting. So let's take a look. we have a way to actually make this a bit more interesting by using zlayer debug and tree. And if I save this, we have just, is it possible to make this a bit bigger? Yeah, great. Okay. Now we can see that ZIO is actually printing our application's entire dependency graph. Okay? So you can take a look here. You can see that here are the HTTP server settings, the default settings, and here's the app config. So these are these are layers that does not depend on anything else. So these are just layers that we can just provide out of the box. But the election server here is depending on the election service. And the election service, in turn, depends on the database and the app config. And if we look at the validation service, the election service depends on the validation service, which in turn also depends on the database, which in turn depends on the app config. And if you take a look here, you can see that we've only provided the database once, right? Even though it's used and app config as well. So even though app config is used in multiple places, we've only provided it once. So the ZIO will take care of your entire dependency graph for you. It will automatically initialize all of these services, and then in a resource-safe way, and it will close them. And it will also do so in parallel. So as you can see that the HTTP server settings and the app config, they don't depend on anything else. So they can be created in parallel. And ZIO will know this and take care of that for you. And also, another thing here is that we can provide these in any order. So I can put database at the top, and it will still work. So what we have is compile time dependency injection, and we have great error messages guiding us in an iterative fashion to provide all dependencies. And then we also have parallel initialization of our services. So this is some of the things that ZIO has to offer, and I think we can head over back to the slides. Let's look here and then play this again. And yeah, hopefully I've shown you the way ZIO and Scala goes hand in hand, and that ZIO can leverage Scala's type system with the bottom types and the top types to provide you really nice error messages while you're doing your everyday coding. And yeah, and I think ZIO kind of fulfills this mission that Martin Roderski had when he set out to create a language that uses two big paradigms that had not really been combined before. And if you're interested, I will publish the source code at my GitHub here, github.com/Ghidei. This is my last name, and then you can just look for Func Prog 2022. And if you want to take more look at ZIO, you can head over to the official documentation at zio.dev. And this has seen a really big, massive overhaul the past few months. So you should really take a look. It's really comprehensive. And I think that is it for me.
Thank you thank you very much.
Yeah.
Yes, great. And of course, we'll publish all links, everything below the live recording, and also below anything we publish. We had one question actually.
Mm-hmm.
They wanted you to show testing.
So
head back to the code and show some testing.
All right. So let's do it.
Yeah.
Okay. So
we got one request. Can you show testing in Scala? And I said it will come later. And now now it's later.
All right. Okay. So
and then I will hit you with some other questions.
All right.
Start with that.
Okay. Cool.
Yeah.
So I'll quickly. So we already gone through. So maybe I can make this full screen somehow. Or no, it is full screen. Okay. So what we can see here is that what I'm using to test my stuff is a library called test containers, and it's a really awesome library. It spins up Docker containers for so you can test your code, and it handles that automatically for you, and you can do it programmatically. So what we're using for our database is Postgres. So I'm depending on ZIO test containers for the Postgres module, and all I need to do is provide a Z layer for how to go from this container to this database config, which is what my database depends on. So if you look at the database here, so my database, I have a layer for it, which depends on the database config. So this will specify the URL and username, password, etc. So let's not dwell on that too much, and take a look and write a test together. So we're going to be using ZIO test, and there's a cool concept in functional programming, which is called property-based testing. So what we want to do is we can write the first test, which is we should be able to insert a party. So what we can do is we can again create a for comprehension. So let's do database insert party, Okay. Insert party, and I'm going to say vol party equals question mark, and then I'm going to yield. We're going to just quickly say assert true here, true, and I'm just going to import. Okay, so and we're going to pass this party. Okay, so let's get back to property-based testing. So what I could do is I could create a party here by myself. I could say party name, foobar here. Okay, but this would be very tedious. First of all, I would only be testing. So imagine that in our database, maybe I can only insert parties with characters less than 10 characters, right? And if I would do this, then the test would pass. Okay, but I would not know that I had a max limit for more than 10 characters. Maybe my database doesn't support all characters, okay? And so in order to test those edge cases, we don't want to spend time creating 20 different instances of party and manually changing the characters. So what we can do is we can use property-based testing. So property-based testing is, I prepared this beforehand, so we can call the generators object that I have here. We can take a look at that later. So what we can do is we can say gen party. And this check operator will expect us to provide it to test given a party. So we will have a party here that has been generated by this generator. And we can use that to pass the party. And our test here is that we just want to say that this database, this insertion succeeds. So I don't have a value here to test, right? I only want to test that this insert party succeeds. So I can just do assert true and then pass true, right? But there's a shorthand for this, so we can just say assert completes. So we can just say, I just want to assert that this insert party completes, okay? Maybe there's a assert succeeds even. No, so completes is the one, okay. So let's go ahead and run this. So we're going to head over to the terminal. We're going to go to the SPT console, and we're going to say test. And maybe I need to reload. Okay, cool. So let's do it. So I have some warnings because we're on the presentation branch. Okay, yeah, this does not run. And the reason it did not run is because I have a ZIO aspect on add ignore, and we don't have time to go through what ZIO aspects are, but these are pure value function transformations. So this is not any Java hack. This is a pure value, and we can actually see here. So this is just a function. Okay, so we can inspect the code. So I'm going to remove that annotation, and we're going to run this test again. And okay, yeah, this is actually interesting. Good that we saw this. So look at the error here. The error is that we have a unique constraint violation. So remember that so this is something that, this is very good actually. The property-based test actually found an error here. So what it did is that it generated parties with the same name twice and inserted it in the database. So we're actually running this like hundreds of times, okay? So it actually found an edge case where if I insert the party with the same party name twice, we're actually going to fail. So if I only created a party like I did before and passed a party name, then this test would have succeeded, because I would not have tested the edge case where I'm violating the unique constraint violation. So the way we can do this, fix this, is by I have a package private delete all rows. So if I delete all rows before inserting a party, then we can actually test the invariants that we're looking to test. So let's do that. Let's run that again. And you can see that this test actually took 2 seconds. And the reason for that is because we're running this with a lot of different parties. So maybe, yeah. So I hope that was a quick peek of how that works in Z.
Thank you very much. Yeah, I hope. It looked very good,
yeah.
Actually. I myself have a background coming from testing, so it looked very good. Very nice. Yes, let's see. We haven't received any more questions, so I will shout, or I will ask some questions, not shout. First, very courageous to live code.
It went well, though.
Yeah, it went well. So well done. Really good done. It's always like bit where it doesn't compile. Exactly. Everyone else sees it. Really courageous. How come you went into functional programming in Scala in the first place?
Well, as I said before, I did my master's at KDH, and there is a professor there who is one of the creators of Scala. He's like a big contributor to Scala too, and he was a professor there and had an interesting course in compiler construction, and that is how I got into it, and kind of been hooked ever since.
So you got hooked.
Yep.
And after that, it's kind of,
Yeah.
you're into Scala.
Of course.
Yeah.
That's how it works.
How come you found Ziverge, or they found you?
Well, as I said, I've been a huge fan of Scala for a very long time, and then there was this new library called ZIO, and it was creating a lot of ruckus in the Scala community. It was coming with a lot of innovation, so I started following that ecosystem very closely when I was doing Scala. So I was doing Akka before at work, and then I asked for permission at my work to create a small microservice using ZIO. There was not a release for 1.0 yet. It was like a release candidate. So I created a small microservice using that, and then I just was super interested in ZIO, and then I applied for the company. Yeah.
There you go. See, really nice.
Yeah.
Yeah. Thank you. It was a really nice presentation. I liked it a lot. We don't have any more questions, so again, thank you very much for your presentation.
Thank you
very much. We'll put it out as we said, and we'll post all links and everything, so you can find the code.
Yeah.
You can go there and hack away yourself if you're interested. Yes, with that, we will head over to our next presentation, and welcome on board, Nick.
Hello. Greetings, everybody, from Philadelphia over here in the United States.
Welcome, Nick.
That was a great first presentation, and I'll just try to keep the standard high over here.
Ooh, thank you very much.
So yeah, I'm talking today about Clojure, particularly as a choice to use for your startup. And so, you know, many of us like functional languages. There's always maybe some sense of thrill about the idea of using one on the job. But from the other end, as a founder, isn't that sort of a reckless choice? So I'm talking essentially about how I don't think it's a reckless choice. I think it was a very sensible choice. Just a bit about me. So yes, at university, I was a physics major, had just a couple of programming classes from around here in Philadelphia, which a city about 90-minute train ride from New York. It's where the Declaration of Independence and the U.S. Constitution were written. Those are our main claims to fame. And yeah, after a year or so out of university, I found myself working in a research lab at the university within the medical school, just kind of learning programming on the job, and had the chance to also take some courses at the university. And yes, the second semester of the Java course, the professor took one day to introduce this language, Scala. So this was probably about 2011. Language, I think, was still relatively new to the scene, and he talked about it being just something really big, and I took to it from the beginning, was somewhat involved in the Scala community for a time, but when it came time to find a job, I just ended up getting a job at a Clojure shop. Worked there for a couple of years, took a few years more or less off, just kind of freelancing, and when I came back to work for Crossbeam just about 4 years ago, which was the first year of the company's existence, ended up also being a Clojure job. So I think after the second time, I'm officially a Clojure guy. And yeah, as the company grew, as the team grew, we found the need to add a management layer. And so about 2 years ago, I moved into management. We have, the company is called Crossbeam. Each of our engineering teams is named after a type of beam. And our team, with a bit of a sense of humor, I like to think, decided that we would be the Pinto Beams. And that's why the character sitting on my shoulder over there, you might wonder what it is. It's actually a stuffed can of pinto beans. So that's the kind of thing you get to spend your day job doing once you're in management. I'm enjoying that. But still a hacker at heart, and really like this topic. But I want to frame it. So I was not by any means the founder. I was just an early addition to the engineering team here. So our founder and CTO, Buck, is really the star of this story. If you've seen the classic 1993 American film, The Sandlot, I think I'm going for a similar dynamic here, where, okay, it's really Buck's story, but the narrator, small as in the movie, corresponds to my role here. So again, I was there, I saw the story, had maybe some small part to play in it, but mostly here to tell Buck's story and have had the chance to work closely with him and collaborate on the message that we're giving here. So just to give a little outline of the talk as it lies out. So I want to talk just in general about this question of choosing a language for your new startup. And there's a good deal of storytelling here because we are telling Crossbeam's story through the lens of these principles here. Though we do think there's something sort of generally applicable here, but also in every case, definitely particularities, contingencies, and so the history has to be told. I mentioned along the way, going to introduce a unit of measure, which is actually just a fake imaginary unit of measure for the sake of having some numbers in a little bit of a model of this complexity that we'll talk through and tell more of the story. And then, depending how much time, can go into the very practical question of, okay, well, let's imagine that you're going with this niche language. Isn't that going to hamstring you when you need to hire? Maybe it's well and good to get to 7 employees, but can you get to 17? Can you get to 70? And I'll talk about that dynamic as well, again, depending how much time that there is. So yeah, just to frame this question, you might, oh, really? One moment. Is that any better? And this is probably also the same. Let me just fiddle with the USB cable here and make sure that the actual microphone here is going to work. I'll plug it into its own port. Is that any better? Hello, hello? Hello, hello? I've also lost any audio signal from you. Hello? Well, I'm afraid I can't hear. I'm just going to rejoin the call. Hello? Okay, all right. Well, that's regretful. have this nice microphone in front of me. Seems like it's just not working, so using a backup. It's good to have a backup. Okay, to frame all of this, when you're starting a company, you might just think, well, you should use what other people have used. These are the RedMonk language rankings that they come out with, and towards the top you can see the familiar suspects: JavaScript, Python, Java at the top. Trailing there, you've got PHP and some variants of C. Then you've got just a long trail from there. Clojure is kind of back here. I don't really think of Fortran as a peer that I want to have. So, well, if everybody else is sort of making these other choices, then doesn't that give you a pretty good idea that those are the right choices to make? So to address this, there's a quote from Steve Yaggy, a known engineering thought leader. He actually wrote the foreword to one of the better Clojure books out there, the Joy of Clojure. And Steve asserts that the industry is really just driven by fashion to a degree that would embarrass designers from New York to Paris. So I think really the thing is, when you're starting a company, you can't run an experiment. You can't say, let's just try this once in this language and try it again in that language, or you wouldn't divide your resources in half and, sort of do a non-deterministic approach. You really only get one shot, just as if we all do in our human lives. So in something that feels very high leverage, most people go with what seems like a safe choice, something that at least lots of other people have gone with, and we all seem to do okay. So nobody ever got fired for choosing IBM, for example. And I think that really explains a lot of what you see out there. But you do get some glimpses of this alternative world. I think the most famous is this essay from Paul Graham about beating the averages, which, he and his colleague using Lisp ran circles around their 20 to 30 competitors. And it was really the power of Lisp that he attributed to that. And then, just 1 year ago, about in this very meetup, we heard from Adam about their experience at CodeScene, first implementing something in one language and then implementing in Clojure and finding how much better, how much easier, how much faster it was, even though Clojure was unfamiliar. So I'm aspiring here, if nothing else, to just add another datum to the story, which is Buck here at Crossbeam. And you'll see how we ended up starting with Python, but then moving on to Clojure. So let me just give a little introduction to what Crossbeam does. And essentially, we are writing software for people who work in partnerships between SaaS companies. So let's imagine you sell French fries, I sell hamburgers. We're not really competitors because people who buy your French fries might want to buy my hamburgers. So we actually have a formal relationship, partnership, where we help one another out in the sales process. And there just haven't been software tools written specifically for these people. And Bob's, our CEO's previous ventures had really run across this problem and thought it was sort of a glaring opening that really needed to be done here, because there is a lot of benefit to be done through collaboration. But if it's not done sort of properly, securely, in a controlled fashion, then you have this sort of prisoner's dilemma where the party sharing more is actually a disadvantage. So we built something of a platform where we both channel our CRM data into the system, and then Crossbeam tells you when there's a match according to prearranged sharing relationships. That's in a nutshell. So again, you have Bob. This is back 2018 or so. He has successfully exited from 2 companies actually, but hadn't yet really gotten the big one yet. You can just do a web search for this title, My $2.6 billion Ecosystem Failed. And you can see exactly how the previous go around, they missed the boat. Essentially, he was saying by trying to be a platform when they should have been an ecosystem. Whereas here at Crossbeam, we have the point of view that ecosystem is everything, that the other companies that make your company more valuable, matter a lot more, a much bigger effect than other things you might look at. And then you have, again, the CTO, who I mentioned, Buck, who had worked with Bob in previous ventures and was out on his own doing sort of some consulting. And he met Bob and agreed to essentially write this prototype for this Crossbeam idea that Bob had. So what did he write it in? Well, he didn't write it in Clojure. He chose Python. And so I think that does illustrate, again, that every choice here is contingent and based on particular circumstances, and it's not as if there's just sort of one right answer. In this situation, Buck didn't know at the time that he would become the co-founder and CTO, and so this might really just be an engagement to get the prototype off the ground and then to be handed off to somebody else. In fact, Bob knows a little bit of Python himself. Knew PHP as well, but let's not talk about that. And so Buck knew Python really well, knew it would be easy to find, somebody else to take it over in Python. Bob also knew Python. That's sort of the lingua franca here, and therefore he went with Python here. So, year one proceeds. They raise a seed round. Buck does decide to come on as the CTO. You can see on the left here, there was a summer of interns who did, a lot of things at the very, very early stages here. And then, year one, there's a first of hiring. You can see me over at the rightmost here. This is our first year holiday party. So I had the chance to join pretty early on. And this prototype became production, and it wasn't just used for demos. We actually had some customers from a very early stage, and this was news to me. I, was accustomed to working for startups that weren't actually following that success trajectory that all of us aspire to. And so in this year one, though, we were already starting to feel some of the limits of that choice of Python. So indigestion, and there's a little bit of wordplay here because the specific system that Buck was working on here, the specific process is ingestion and matching. Remember I mentioned that each of the partners channeled their sales pipeline into Crossbeam, and then we ran matching on it. And Buck had this all written and working in Python. And he just found himself looking at something he'd written actually not very long ago. And it wasn't actually that complicated, the inherent behavior that he was trying to express in Python. It wasn't actually rocket science, so to speak. And yet he found it surprisingly difficult to figure out how it worked, even though, again, he was the author of the code and it hadn't been that long. It took him longer than expected to make this actual change. And this just gave him a real sense of pause whether Python was going to make it for the long haul. So you have to have this perspective. Again, you start small, but you're going to grow. And indeed, we're about 4 years in now. We have crossed about 100 employees. We're over 30 engineers now. And it was still really enough to have second thoughts here and think, should we be doing something else? And it really comes down to this question of complexity. When you're writing code, you are spelling something out in such simple terms that the computer does exactly what you say and it will be the right thing. So you've got to make sense of the complexity. And you've got to think in terms of how much each engineer can unravel, especially knowing that it's not simple to just add engineers to the problem. By analogy, you could think of an algorithm that takes a certain amount of processing power, and you might think, okay, well, my processor is maxed out, but we can go concurrent, we can go multi-core, we can go distributed, and we engineers know how complicated all of that is, how hard it is, and you have somewhat analogous, I think even more intractable challenges when you're trying to get more humans onto a problem in such a way that your marginal engineer actually makes the whole unit faster and more productive. So thinking about this concept of complexity as sort of the most important factor when considering building software systems Because we have to deliver a lot of complex behavior overall. You're trying to encode, this data sharing, which can happen at scale, very securely. And every time you're adding features, you're adding complexity. So how do you actually unravel, swallow, handle that complexity while keeping from getting tripped up by incidental things, such as the language that you're trying to encode this in? So I'm introducing a made-up unit of complexity. Let's call it the Goldblum, after the actor Jeff Goldblum and his famous character in the movie Jurassic Park, with this scene in the middle here talking about chaos, which is a related topic to complexity. So let's just imagine, for the sake of being able to put some numbers into this model, that there's a unit, the Goldblum. And yeah, humans make sense of complexity, but it takes us time. We can only handle so much in a given day. And there's really only a certain amount that any human mind can do. Of course, some of us can handle more than others. Buck handles more complexity than just your average engineer, I think. And that is also factored into the model. And just Goldblum's character would find out that sometimes the complexity handles you, hence the little speech out of the Tyrannosaurus here. So this, again, is just a made-up unit of measure for the sake of having a model that we can use to explain here. Just a little thing I found online, little Clojure lazy sequence there popping in there. Okay, yeah, so I've got a spreadsheet. This is not live coding, but this is just a spreadsheet. Let's examine the little model here. In the left column, you've got the number of engineers on your team. So engineer number 1 here would correspond to Buck. And then again, as I said, I think humans have a variable capacity to handle complexity. So let's say that in a given day, engineers can handle a certain amount of Goldblums. So I'm taking for granted that sort of your first few hires you can maybe know more about, and I'm saying that somewhere between 10 and 12 Goldblums are the early engineering hires. But that as you keep growing the team, you of course do your best in your hiring process to find the best engineers, but you still can only know so much. So I just have it as a random, somewhat lower number from engineer 4 onward, between 6 and 10. And another feature of the model is I'm saying that expressing the same system behavior in Clojure versus Python will require you to make sense of less complexity. Will use up fewer of your Goldblums. And so, yeah, let's say that in a given day's work, expressing the same behavior in Clojure will cost you about 2 Goldblums, whereas the same thing in Python, let's say it costs about 5 Goldblums. So in that case, each engineer's Clojure productivity would be just a simple difference of their Goldblum level and the cost for Clojure, likewise with Python. So this is sort of the first order effect here, and this will be enough to go on. I've actually presented similar idea before with nothing more nuanced than this. Essentially, if you have a tool that is making every single engineer more productive than just by itself, it, I think, would be worth going with. But I also wanted to try and incorporate into the model some idea of the cost of coordination. And the point here is that as you add more people to the team, you have to spend more and more energy coordinating between them. And this is just extremely rough, not a refined idea of how coordination scales with the size of the team. I just have it costing half a Goldblum more as the engineers come. So that gives you a chance to, again, just do a simple difference for each baseline productivity and say what the net productivity is, factoring in the cost of expressing it in the language, as well as the cost of coordinating across the team. And you can see there are, every time I edit a cell in this spreadsheet, the random numbers will reshuffle, and so we could get a few looks at this. But with this particular one, it's not even a guarantee that you add an engineer and it helps the team be more productive. You've got people, a few hires here. This is actually a particularly unlucky run, but essentially your first 3 engineers would be more productive than you added 5 more engineers to the team if the language is Python. Whereas at least you're still getting, more productivity in a less complex language. And so you can just look at the productivity of the teams here. And once again, you've got this velocity that's obviously much higher in our simple model for a team that's using an expressive language like Clojure versus, just a much less productive team in Python. So sure, I don't know, I can just trigger a couple edits here to see if there are any really interesting features that come out here. But I think essentially this is the story that I aspire to tell here. And the thing is, though, I stop at 8 here for a good reason, because the coordination cost, once you get beyond about 8, really just becomes intractable. 8 is roughly what I think of as the highest number of engineers that you can have on the team. And at that point, past that point, you need to just split off, divide into 2 teams. And as I mentioned, that is a transition that we've gone through here at Crossbeam that coincided with me getting out of the coding chair and into the management chair, which right away shows you have a productive contributor who no longer writes code because of coordination costs. But yeah, 8 is about as far as you'll get. So let's go back to our slides here and discuss the features or the conclusions from this model again. Again, if you're only looking at the value per engineer, then even in that case, Clojure would be, I think, a better choice to go with. But there are also just these very fundamental limits of teams that go with the coordination overhead, communication problems, and so on. Adding more people to a team doesn't necessarily make it better. Adding engineers to a project doesn't necessarily make it deliver faster. That's the essential insight of this classic mythical man month. And so at a certain point, well, you just need to add teams, but adding teams is hard. You've got to figure out the natural limits of the system that can actually be divided such that one team no longer needs to think about the domain of the other team and vice versa. It's very hard to get that right, and you need to make technical investments to actually make it work out. So, okay, what do, obviously, those red month rankings still have those tried and true, so to speak, languages at the top. And that is what a lot of companies are doing. So, well, what exactly do they do? How do they handle this? And I think the biggest answer is they go with microservices. And, at a certain point, you do need to split into multiple services. But they basically end up needing to do this much earlier. And the team, again, let's just think, that team velocity on Clojure with 8 engineers was in the ballpark of 45 Goldblums in our model. It was only about 20 Goldblums in Python. So that Clojure team can actually handle more than twice as much complexity in their domain. So you would need to split into teams less often. You wouldn't need to go to microservices nearly so soon. But as mentioned, he's talked to different CTOs. He's heard different ratios of microservices to engineers. And yeah, he's heard, for example, 20 services for 30 engineers. And that is just a huge ratio because the complexity doesn't go away. You just push it from the code into operations. And suddenly deploying things, running things becomes a lot more complicated. So having each team be able to handle a lot more before they need to go. And I don't really have time to go into it, but there are also features in Clojure that make it so that you can have any of the benefits of microservices without the operational overhead, because you can still use a mono repo for a much longer duration. So yes, we are at about 30 engineers, as I mentioned, and we still just have the one Clojure service that gets deployed. And our different teams have their own slices of that, because Clojure's component system essentially allows us to have those boundaries of ownership without having the different operational overhead of different services. So yes, I think essentially what companies do is they go with microservices, as the tweet comically illustrates. That also introduces problems. And so ultimately, I think most companies end up just paying a huge tax here because of the language not handling the complexity for the engineers. Okay, so what happened in Crossbeam's case, though, as I mentioned, we had this sense that Python might not be good for the long haul. But we couldn't just, close up shop for 3 months and rewrite all our code in Clojure. It had to be bootstrapped, and I think also with the right mindset here. So yes, by this point, we have expanded our team. There was a Series A. We made some more hires. We got more engineers. And Buck is working on a proof of concept Clojure service in his nights and weekends. And it was not intended to be a full replacement of all of our Python code. It was intended to be just this core matching subsystem, sort of the most complex piece of our systems to that point. And so get the most bang for the buck, buck, no pun intended, by just going with the subsystem there. And again, you wouldn't, in this realistic setting, think of a grand rewrite where, yes, we'll just completely throw out our code and do that. But it actually ended up happening. So, okay, we went live with this Clojure service. It's called Muncher because of the ingestion matching initial thing that it handled. And we went live in production with that. We cut over matching to that. And we have our Python service and our Clojure service running in conjunction in production. So at this point, Buck has a chance to do that point of comparison that I mentioned is all too fleeting. Adam mentioned it in his talk a year ago, where they had written in one language and then they rewrote in Clojure, where they had a sense of how much better that was. In this case, you have equivalent system behavior that has not been rewritten in Clojure. And Buck finds himself looking at fairly complex code that was written a while ago, and yet it was much easier to figure out how it worked. So this is the anecdote that fleshes out the feature of the model here, where the fact that this was in Clojure allowed it to be a lot more comprehensible. And yes, this rewrite essentially, gradually, by stages did become grand. We ended up about a year later removing the last lines of Python from production. And there were two reasons for that. The first reason goes back to that same thing we mentioned about the operational complexity and overhead of microservices. So we didn't want to rewrite the data layer code in the Clojure service. So Clojure calls Python via API. So to make any change for something that the Clojure service is doing, you have to go and write Python, redeploy it. And yeah, it was just a little bit of a headache, even at n=2 services. That just felt like a pain. So yeah, I was on one of the first new features that we built after the launch of the Clojure service. It was a data request feature to say, hey, partner, can you share this data with me? And we came to a little bit of a crossroads where we considered, should we implement this in Python? Should we implement this in Clojure? And we knew at this point that if we implemented this in Clojure, that it was going to be inevitable from that point to end up rewriting all the Python code. And well, that seemed a little bit intimidating, but at the same point, at the same time, all of us on the team at that point had prior experience with Clojure, and we just had an idea of how fun it was going to be. The idea of writing on Clojure just was a lot more motivating. So in a sense, we went for it. And I think that's actually important. I don't want to overlook that as us getting irrational, because again, these systems are written by humans. And if we already knew by experience that Clojure was going to be more satisfying, that we were going to be more productive, it was going to be better quality of life, then I think it was fair for us to make that choice, even for the engineering team that we couldn't foresee, even though we had an idea that it would keep growing. So again, there was this idea, okay, well, this is too complex with 2 services. And then also there was the sense of, well, wouldn't this be fun? So every project that we did, we just did a little bit of Python migration. at the outset. And then at a certain point, we had rewritten enough of that we were able to bring some people on specifically to help us with migrating the Haskell to Python. And yeah, so before year 3 had dawned, we were fully running on Clojure here. And that was how that happened. So that does raise the question of, well, okay, we do Clojure on the team at the time, and that was certainly part of how we felt secure enough to go with it at that point. But can you actually hire an engineering team and do that for the long run? Again, in this sort of niche language. And yeah, I have some more slides that I'm going to go over somewhat more quickly here, but the short answer is that, again, we're just about to split off our 4th core application team and just about 30 engineers. And the short answer so far is yes, if anything, choosing Clojure has made it easier to hire good engineers for our company. So, and it has looked a little bit different in different phases. That Series A round, which were the first hires outside of the core first few of us, yeah, I brought in somebody I worked with at a prior Clojure shop. So it certainly helps to recruit him. But also had a former colleague who used Clojure, and he came aboard. We hired a senior engineer from another Philadelphia company who had only worked at Scala before, but for whom this other functional language was a compelling choice. And so, yeah, even though it wasn't through the network, was also through this functional language. And so, you know, a year later, we had a Series B hiring round, and we're trying to double the team again. And our persona started getting a little more varied at this point. So we're still getting sort of Clojure veterans, people who know Clojure, people who are looking for Clojure jobs. We also got, for instance, somebody who had worked his whole career in Java, but was really interested to try out this Clojure job. And we also wanted to get out of just hiring sort of senior and higher engineers and begin to hire mid and associate level engineers. And you know, fewer of them had used Clojure before, so we had to have our first experiences really teaching new engineers Clojure on the job and see how that goes. There was also a Series C after that, and we've just continued to hire more. And again, we have a mix. There are people who just happen to stumble upon Buck's blog post about using Clojure, and who, even though he has a really good job at a publicly traded company as a staff engineer, just wants to get out of Java land and try something in Clojure. We had that persona found his way to us this year. We have other people who, again, have no background at all in Clojure. And we've had the chance to really focus on the onboarding and the learning process there, and to have really good success stories. I've got a couple on my team of people who have come in and shocked me within 6 months or so how fully they internalized the power of Clojure and so forth. So essentially, it's worked out. And it's actually, Steve Yankee makes the point in a recent talk he gave advocating that people learn Lisp. It's actually not that hard to learn a language like Clojure. It's not, it's a little bit of a different paradigm if we're used to the same old imperative way of doing things, but it's not that hard. And it's also not that crucial part of a person's job in some sense, because an engineer has to do so much before you're writing any line of code that doesn't have to do with expressing it in the language. In fact, my old mentor, Kyle Burton, would say that writing lines of code is one of the least effective things an engineer can do. So yeah, you can teach it. It's not that huge of a part of the day job for an engineer. And I just popped out my headphone cable 1 second. Yeah, then it does become not just a recruiting, but also a retention advantage. People get used to using this expressive, powerful language, and they're not interested in going and doing something else. Don't want to go back to the land of curly braces. Sorry, that's meant to be, really C represented there. Nothing against Scala. I think many of these points would go for other functional languages as well. And yeah, we've just had to continue every year. It's its own story. We've had success outsourcing to Clojure devs because Not every person who knows Clojure is a great engineer, but there's definitely some signal there that there's a correlation. People who gravitate to Clojure tend to be better engineers. So even though many companies struggle with outsourcing, we have some collaborators in Europe who have done really well for us. They've been part of our team over 2 years now. And again, Clojure was a big part of the success there. We've continued to grow teams. We've gotten a lot more serious about getting the separated ownership and domains so that each team only has to handle so much of that complexity. And we just added so much complexity to our Clojure code base since it first dawned. And yeah, of course, one feature I would change about the model if I got more sophisticated is that the cost of each language wouldn't just be this constant integer, but that it actually is something that varies with the lines of code. The bigger the repository gets, I think there's sort of more complexity challenges. And it's not that you don't face that at all in Clojure, you face it in any language, but we've had to continue to do more work to sort of make all of that tractable. And yeah, that's essentially what we do here. I have a few quotes from the engineers on our teams. One says, learning Clojure was a huge advantage. Other people said, well, we were really looking for Clojure jobs first and foremost. And so therefore, we obviously had a huge advantage at recruiting those engineers relevant to companies that don't use Clojure. And there's also, I think, a really important aspect about the community around Clojure, which is that it tends to be a very positive community that is just really happy to be here. We went to the last Clojure Conj 2019, and there Rich is with his entourage, and everybody's just talking about how great Clojure is. And of course, you could worry a little bit about groupthink, but I think it's a sort of small enough tribe that we're not really in danger of, losing our minds. And because the Clojure community is this diverse entity, it is a really positive thing to bring engineers into from outside the community. And again, in terms of hiring and running our team, it's just been a huge asset. So yes, again, Clojure makes each of our engineers more powerful, we believe, and it makes possible for each of our teams to manage systems with a lot more complexity. Again, I think it's more like your team has a budget of 45 Goldblums before you need to split off a new team versus, say, 20 Goldblums. And if anything, it has only helped us with recruiting and retaining rather than being some kind of challenge. And yeah, we know other companies, Nubank is out there, they have hundreds of Clojure engineers. So we certainly know what can be done and that there's a growing pool of people who are already in Clojure. And so having gotten to 100 employees, 30 engineers, we have pretty good confidence of being able to continue to go through the next milestones of growth. So that is my presentation. And because I pulled out the headphone cord, let me make sure that I still have audio.
You do. We thank you.
Yes, great.
Thank you very much, Nick. Thank you very much, Nick. Thanks.
You're welcome. And sorry about the audio trouble.
Yeah, no worries. It's if you work with software, it will happen. You know that you will fail in production sometimes.
Indeed.
It's just how it is. It's life. Thank you very much. We also have some people in the chats saying that they're also like the Clojure community is also part of choose why you should go to Clojure. Anyway,
wonderful.
Yeah, I just want to mention that as it's shout that out. Well, thank for your presentation. I think it's really interesting this you talk about the complexity things. Have you done more things around this? The what do you call it? Goldblum's matrix or revenge. I mean, that would be really interesting to start, comparing different languages, because a lot of companies today they just choose something randomly, or we go with the popular stuff, Java or C#, or without making a conscious choice for the long term. More like we do this now. In the end, we're 200 devs. We're working on this,
Yeah, so this whole Goldblum idea in a spreadsheet is just something that Buck and I came up with in the last week, and it is just sort of a rough idea, and I would like to explore it further. Buck had some idea for you might be able to study it further, perhaps even a natural experiment looking at repositories on GitHub in different languages and how many people are contributing and so forth. But I do think it's quite deep. When I first started presenting on this idea, the intended audience were Clojure enthusiasts who would just be craving for the chance to use it in production and would live vicariously through the story. As I've thought about the subject more, I've realized that there is something really potentially very deep here that not just the Clojure enthusiasts, but anybody starting something should think about. So.
I totally agree. Me, myself, I went from, I did C, C++, Java, and then 2008-9, I learned Erlang. And I had kind of the same feeling going from this to Erlang, is that it's less complexity. It's much easier to make the right choices as a developer. And then I had this thinking myself then, why, if you're a huge company or a small company, why don't you choose a language that's going to help your developers? Because in the end, it's as you say with the matrix you show, like you end up with the gazillions of developers. You want to maximize their productivity. Yeah. Another thing, have you elaborated around team sizes and optimal team sizes, as you mentioned also in your matrix?
That really just comes from my experience the last 2 years in management. Maybe there will be different ways of running a team, but for instance, my team these days has grown to about 9 or 10. And just as the manager, it is really hard to stay on top of everybody's work stream at even that size. And so I mentioned we're about to split into 2 teams. So that's just kind of our rule of thumb. I don't know, depending, exactly how you run your teams, maybe you could have more on a team, but it does seem like around 8 is a band where everybody can be familiar with one another, familiar with the systems, good amount of redundancy, but not getting to be too large and too unruly for a manager to keep track of.
Do you see any uptake in the local community where you live around Clojure once you get started? I mean, the rumor spreads, you recruit people, maybe you get grads in, they will learn, things slowly. Do you see that?
I think honestly that's the story that we're in right now, because that first Clojure shop that I worked for was around 2012, and that's when Bob was also doing his first company, which also had Clojure. So our city, Philadelphia, is a little bit of a Clojure hotspot, and we have seen, again, here we are, we have a lot of us, it's not even our first Clojure job here. So yeah, in short, I do think we have seen that story, and I'm interested in seeing it continue as well.
Nice. I don't have any more questions. Again, thank you very much for your interesting presentation. Thank you very much.
Thank you. It was a real pleasure.
Yeah, you're welcome.
I'll see you in Sweden next time.
Come to Sweden. And before we started the live show, Nick said that he knew fika. So if you ever come to Sweden, you have to have fika. It's kind of the tradition in Sweden. Or if you work with Swedes, you know that fika is a tradition. Yes.
Got to experience that.
The Swedish fika. Thank you again, Nick. And if you come to Sweden, please ping and we'll have a fika so you can have the experience.
I'll be sure to. Thanks so much and have a great day or evening.
Good evening. Thank you very much. With that, people, thank you very much for listening in today, and thanks for all your nice shout-outs and comments in the chat. Also, we'll be back again in a month. Now we scheduled 3 meetup events, 1 for October, 1 for November, 1 for December. We have one presenter for each of these meetups, but of course we're looking for more presentations. So if you have a presentation, you want to present something, anything around functional programming from anywhere in the world, please reach out to me. You can find me either on the meetup page or on LinkedIn or in any social media. Just ping me and we'll put you on. And with that said, thank you very much for tonight and have a nice evening, everyone. Bye.